This conference will now be recorded.
Awesome. I may start. I mean, I can skip around. It's not that big a deal. Start with the bash script and then go to the containers next week. No big deal.
But under normal circumstances, I don't want to put people in their place because, first of all, that makes people.
Oops, that's not what I want to do. I want to hit escape. And the only reason why I say I'm not doing that right now because when I have a lot of people on and I don't want to go through containers. What not a lot of people on right now. And then we get a whole bunch of people and then we have to go through it again, which is not a big deal, but that's not what I want to do either. Let's skip that because I need my screen. That's from last week. Quick Chrome. Yep. I knew that was gonna happen. Yeah, that's fine. All right. 134. Here we go. I can easily do this on my computer, but I want to do it in a Linux environment. Let's SSH to the machine. Should be able to hop onto that machine. Scrub the public IP. It should have my key up there. You know what? It may not, because this is a different laptop. It may not have my key. I may have to add it because this is a different laptop. I'll show you how to do that. All right, let's go down here to the metadata of this because I don't have my SSH key set up for this. All right, so here, what we're gonna do is I'm gonna do it ls minus a. I do have one. No host. Okay, nothing there. All right, cool. All right, and I'll delete this one since it's being recorded and probably be put on the internet. I'll delete this after we get done. But for right now, this works. Save. All right. So now if I come back over here to my compute engine instance, okay, cool. All right. Oh, you got observability in now. Pretty cool. Why I'm not seeing my public IP? There we go. All right, clear. All right, so now we're on the machine. So that's how you set up on GCP. Generate your key gem, or generate your key. You're basically using RSA, upload it to metadata, find the public IP, then you should be able just to SSH over to it. And if you want to do all that from command line, you could. All right, so in our 134 class, the kickoff is writing simple bash scripts, how to use loops, matching text with regular expression, and we've gone through regular expression with offset, grep, offset, grep, cut. I think you can use. I think xargs falls under regular expression, but primarily offset, grep, cut is usually what you find. And then they have a lab for you to do that in. And then let's go look at the summary. In the summary, you learn how to create and execute simple bash scripts, how to use loops to iterate through list of items from the command line in a shell script. Oh yeah, and all those for loops with less than, greater than, equals to, does not exist, and ors, logical and logical ors. It's all part of scripting, and they're also found throughout all of the text when it comes to whether you're using Python or Go or what have you. You'll find regular expression pretty much throughout that. And then how to search for text in log files and configure files to use regular expression and grep. All right. So when I talking about regular expression, if you went and looked up regular expression Python, um, it's the RE module. And in here they talk about, pretty much regular expression. I'll give you this link so you can have it to look up and understand it. But this is just in Python, right? And then if you went over to regular expression in Go, as you can see, there's regular expression in Go and how they do regular expression, right? And really kind of, not kind of, but it does come down to syntax, all right? So um, the primary languages you'll see, like if you're doing infrastructure engineering, it'll be Python, Go. I don't You'll use Java, but that's for more primarily for application. Perl is another language that people use when they're talking about regular expression, but I mean that's job dependent when you're looking for Perl and so forth. So when somebody's talking about Perl, I should say. But these two, Python, Go, and Bash is just that by default. It's just your what's installed with Linux automatically. Are the things that you use. All right. So let's go back here on 134 and give an overview of what they're looking at. This is the second part of the 124 or the RHCSA class. The 124 is the first one. They talk about what your entry level is. I think what's important out of that 124 is understanding bash, the command line, and uh, how commands work. When I say how commands work, I'm literally talking about, let's say I should be able to sudo in here. Yep. So if I want to copy a file in /etc and it's .net and I want to copy it to temp, you should look at this as copy source. I should put this in brackets and then destination. right? That's how the, and that may be a little small. But that's how the most of the commands are pretty much set up. Let me expand it. Mm-mm. Let's see if I can make my text a little bigger. I'm not seeing that, but I'll make this smaller. Mm, Is that bigger? And also too, Joan, on your screen you can make the text, but you can make the screen bigger as well too on your end. All right. Okay, so in here, this particular lab, they're just trying to show you how everything is set up. You should recognize the CIDR notation here. You should be able to recognize these host names if you've been following along with the class with their environment. And this is the lab environment right here. It's going to create um this lab environment here whenever I can get back to it. It's going to create this lab environment. And pretty much on the test, it probably looks similar to this on the test. And then they break down like what each one is and what they do and what they have on them and so forth, right? And then they tell you how to SSH to the machines and so forth. So I advise you to read through that. Now let's get back into our bash script. So they start off with the shebang here. Um, and I use Vim. You don't have to use Vim. You can use Pico, Nano, um, Emacs, Pico, Nano, Emacs. And Vim. I know I'm missing another one. But in order to, I don't think Nano is installed by default. So let me do a RPM query, and I'm a grep for Nano, and I'll grep for Pico as well too. Yep, it's not installed by default. So if you want to install those, you'll have to do a yum install of Pico and Nano. Um, if you want those. Oh yeah, I forgot. I put my machine out there to Red Hat. I need to probably unsubscribe so I can use the local stuff for the local the Google Cloud stuff. That's what I need to do. Hold on, but let me do a yum repo list. Yeah, it should be pulling, but we'll see. Let me see if I can install Telnet. If not, I'm gonna have to unregister this machine. Okay, it says already installed. Okay, so it's trying to do something. That's good. All right, back to what we were talking about here. So here at the end of your files, at the beginning of your files, if you are going to write a shell script using Bash, you'll have shebang, and then notice they give you the full path or /bin/bash. If you were using Python, it'll be slash user bin Python or Python 2, Python 3, or wherever you have your Python installed, or if you want to use a particular version of Python, that's where you would have that at. In here they talk about the scripts begin with, we call it shebang right here, or shebang or shebang, for those two characters, and they call it sharp bang, and just pulled them together, called them shebang. And it says that this specific 2-byte magic number notation indicates an interpretive script. And that's basically what it is. We're using the interpreter of /bin/bash. If you look at Kickstart, And a kickstart is what actually gets installed on your automatically on your machines. Let me go to it may be here, ls minus a. They don't have one there. No, they don't have one there. But on my VM, whenever you create your local VM and say you did it in VMware and you spin up an instance, you'll get an Anaconda config file. So let's go look at a kickstart example with interpreter. I know I spelled that all wrong. So this works right here. This is verse 6, but I just want to see if they give an example. All right, so this is what I was talking about here. So in here, you specify a scripting language to use to execute a script, and you select the interpreter, just like what they have at the top of this area. This is an interpreter, but you can set that interpreter up to be anything that you want. So here they got user bin Python, and they point to the actual one. And inside of your post script, they specify what interpreter to use in the post. And this particular portion right here refers to a kickstart file, but this part right here refers to a script, just like you would with a script that you're making with Bash or Python, or say you're using something with Golang or Rust or something like that. If you want that script to run as using that interpreter, you would have to specify that path. So that's what they're talking about as an interpreter when they say that. So our interpreter for this is Bash. All right. So then they talk about how to execute a shell script. So here on our Linux boxes, if we cd over to /user bin or /bin, I'm going to clear my screen, and you just do a ls. You see these things, they come up in green. They're actual scripts. And one way we can find that out, if you don't have the color showing, let's just do a file on SCSI stop. And it's telling me right here it's a Bourne shell script, and it's it's an ASCII text executable. So I automatically know. I just know this from being on the file system so long, but I also know this from just looking at the interpretation here when it's green. But if I want to verify, I want to run the file command to tell me exactly what it is, right? And so if I cd over to the var log, right, and let's do a ls, and then let's do a file on messages, you can see it's just an ASCII text. Where up here it told me it was an ASCII shell script and an ASCII text executable. Key phrase here is ASCII text executable, right? Meaning that it's a script that can be executed, can be ran. And then it also tells me the interpreter here that it is a Bourne shell. Now, uh, you can try to open this right here, but you're not going to get anything because it's going to be a binary. Here you can open this particular file. It'll be a message. I mean, it'll have messages inside of there, text inside of that. All right. So here, what they're trying to show is when they say with hello, that's actually, you can run this on your machine. It's not going to work on this one because there's no script in my path, and this is the path that it's looking at: user local bin, sbin, user local bin, user bin, user bin, user sbin, user bin, root bin. It's looking in that path to say, well, you don't have a binary in that path that says hello, right? That's hello. So what we can do, and I can show you the difference here. So when I do which hello, nothing, right? So I know it's looking for all these paths. So let me go to slash root, do ls. There's no bin there. So if I cd over to user bin, right, and I open up a text file and I call it hello, and I put in my shebang. Oops. Shebang. And then I say echo some stuff. That's all I'm doing in that file. That's all I'm doing in that little script. And then I pass it the chmod plus x on hello. Now, when I go to update this, it should catch it, but I think I may need to update the path. But let's just check it, which hello. Okay, so now you see it found that script called user bin hello. It's because I put it there. So that's when you see this return that you saw up here, it couldn't find a script in that path to in the path that have been predefined with the word, with the script name hello. So uh, now if I remove this and I run this again, where's that? Which hello? You see that that error comes back, right? So that's what they're showing here. It's saying which hello. Okay, they actually have something in their path called hello. I placed something there. All right, and then now we want to echo the path. Okay, I've shown you this before, but if you go to etc profile and type in path, this path gets updated. Here you can see path, user, log name. All this is in this particular file, but this is set by the system. So in my path, if I echo $ path, this is my path, and that's really evident when I do which hello. It tells me that I'm looking in the path variable has these paths set up, and it's telling me that these are the paths that are set by default. And so it looks in those paths. If I had hello in say slash temp bin, and I had a text file in there called hello, I would need to add that path, that particular path to the path variable. So let me show you that. All right, so let's go over to temp.
So add that path in your profile. That
I'm
bash.
getting ready to show you.
Okay.
All right, so in slash temp, if I add if I make a directory called bin, so now I have a directory here called bin, and I'm gonna go into bin. Now I'll add this file again called hello. And then we're just making it real simple. All right, now when I do echo $path, that's the path that it's looking for. When I say which, if I cd up to, just to show you, if I say which hello, it doesn't know because that path isn't there.
Mm-hmm.
All right, so now what you have to do is you have to say, you can say export equal to $path and now :/temp bin. Right now, when we do which hello, oh, let me double verify too. Let me echo $path. I may have to add it to the thing. Yep, we didn't take it. I figured it wasn't gonna take it. All right. So the way around that is, and these are the tricks here. So if you want to do it for your profile in slash etc profile, this is for the entire system. And when I say the entire system, meaning if you have some users that log in, it'll be for the entire system. If you want to do it for, I'm a root user right now. So if I want to do it for the root user, do it ls-a. If I want to add it to my profile here, I can go bashrc or bash profile, or I can add it to the entire system. So in here, I can add, this is where you was asking about aliases before, Sasha. These are those aliases that automatically pop up for you as a user.
Yes.
So you can, yep. So you can add your path variable here. You can also go to bash profile, and you can see that they have a path here. So here you got path, home, $home /bin. I can come in here and do, and I think I may have to log out when I do this for it to take.
Yeah.
So /temp, and then bin, and then it's going to export that out. So, and I'll log out, and I should not have to go all the way out because I'm root with that one. And then let me do an echo on my path. There's that, my path shows up. Now when I do which hello, did I name it hello, by the way? I think I did.
Oh, the Vim file.
Yeah, I did. Oh,
Yeah.
hold on.
Oh, Chmotic, yeah.
Let's try that again now. There we go. Now let me go out of the directory to prove to you that was it. Yeah. So the key thing to take away with that is it has to be a binary. I mean, a executable, not a binary. It has to be an executable. So that's why the which didn't probably come up the first time, and then I didn't probably have the path in there the first time either. So now anything I drop into temp/bin that is a binary, and then I do a which on it, it'll come up. So that's one way to add it. Another way to add it is, like I say, you can go into etc profile, and you can come in and you can play with the path variable. Usually most people drop down right here and they just say, okay, well, path equals to $ path, and then /temp/bin, right? This sets it for the whole system. In other words, if I have 5 other users on here, those 5 other users are going to find that particular executable in this particular path. With me setting it up as root, it's only in the bash profile of that one, it's only going to be seen by that particular user. So that's the difference
So root only sees this. So if
for
you go
right now.
under like another user, you gotta set that profile too
That's why etc profile is the,
for
if
the
you want to set
system.
it for the system.
Okay. My other question is, why would you put it in bashrc?
Let's see, cd over to, oh, here, because somebody may want to set something to run at the command prompt. That's all.
Okay.
Some people run it in here. Some people have like a script they create, and they want their script to run when they log in. So every time that
Oh,
user
oh,
log in,
okay.
that
Okay.
script runs, and they may want to set you may want to set their environment up or something like that. Some people use bashrc, some people use bash profile. I've seen both.
Okay.
Because you can see here it says basically if this file exists, then /etc bashrc. So it's running this script bashrc, so you can go check that out. So let's do a file on /etc bashrc. All right, and it's an ASCII text file. And so this comes in, it runs this script. It says, see, system-wide functions and alias environment stuff go in /etc profile. It's not a good idea to change this file unless you know what you're doing, blah, 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 so forth and so on. But it runs all this when you log in. This is why this what gets set up when you log in.
Mm.
So like I say, some people want a script to be ran every time they log in, go out and give me the uptime on the 15 machines just to see if they were up
Mm-hmm.
when I log in. Oh, I need to check them. All right, cool. That's what that is. So like I say, I'm usually setting something for an entire system, so I use bash profile. I use etc profile versus bash profile if I'm doing something for the system. If I'm just doing something for me, then I'll just do it locally. But 9 times out of 10, as an admin, I'm always setting something up for the entire system. All right. So
I
any other
got a
questions?
question though.
Uh-huh.
I remember one time at my job, I changed something in um Bash profile, but I didn't have to log out. I think I did something, like I updated something for
Yeah,
it to
you
work.
yeah, you can update the variable is it the set command sets the variable. I forget what it is that runs it at command line to update it. I forget off
Yeah,
the top of my
okay,
head.
I'll look it up.
I forget what it is off the top of my head that it update it right at command line. All right, so in here now they start talking about quoting special characters. So on your keyboard, and I showed this before last week, you have single quotes, right? And then you have double quotes, and then we have what we call backticks. So let me show you the differences. All right. So we got a single quote, right? And we gonna say e
Oh, you
blah, blah, blah.
sourced it.
Yeah, source. Yeah, you source the file. That's it. So here's the single quote, right? And then here go double quote, right? And then we have what we call these backticks, right? There is a fundamental difference between these. Um, Starting backwards with the backticks that you see right here. If I were to encapsulate that inside of a command or inside of a variable, I'm telling the variable, I am running the command and storing that information into that variable. So when I do a ls minus l here, let's go to temp so we can get some output. So I'm getting some output. Great. That's nice. But now I want to store temp results, right? And I want it to equal to my ls minus l, right? Now I have that information stored in a variable, but now I'm going to echo $ store, and I can walk this through a for loop, but we'll get into that later. Temp results. You see how it's all on top of each other, but that's because it stored it in as an array. But we'll get into the walking this line by line later on. I just want to show you some fundamental differences between the single ticks, the back ticks, and the double quotes. So now I did that with the single ticks, right? So now let's try that with the double quotes or the single ticks, and let's see if we get the same results. Now echo store results. You see, it took it as a string, right?
Yeah.
So now I just return what you told me it should be. It's a string. If I do that same thing with the double quotes and I return that, you see I'm still interpreting it as a string. It's taking the ls, the space, and the minus l and just giving me a string. Versus the backticks that we did prior to that returned me and the actual results of that command. And so that's why you're able to get that output. All right.
Mm-hmm.
All right. So what they're showing right here is um on this one here is how to escape characters. So basically right here they're saying that using the slash allows you to escape a character. So let's do this. Let's do a ls minus l, and let's just redirect into being some output dot text. All right, and let's see the would have been, and there's our output dot text. All right, so in here you can use regular expression, and that's what they're leading you up to try to find out, like, how to escape or how to change stuff. So here I can come in and I can say search colon %s. I want you to search this file for every occurrence of bin. All right, and then replace it with hello, and then do that everywhere in this file. And you can see Ben got replaced with hello. I can hit the undo button and it'll change it back. Great. What to do? We search something and then we change something. All right. So now what we want to do is let's change everything with dash private to dash hello. Let's see if we can do that. All right. So we're gonna go back in here. We're gonna do a search on uh, dash private, which I think should fail, but I'm about to find out. And then we're going to change that to dash hello. Okay, it worked. Now, what usually happens is when you have this, like they got here, they're showing that this is a pound sign right here. They're showing that that's actually not a comment. We want to leave that in there. So escape that. That's what they're showing here. We want you to escape that. So let's test this theory here. Let's do exactly what they got on here. All right. So here, echo not slash echo pound space not a comment, right? So now let's go here, and they're saying we want you to echo this, but we want you to escape that this pound is in front. And so that's how you got the pound, not a comment. And you notice I didn't put it in quotes either. It read everything past the white spaces. All right. So in here it says the back slash escape character removes the special meaning of a single character immediately following it. For example, to display the literal here, they were showing the echo. They were showing using the echo command to do this. We escape this by putting the slash in front. So therefore, we didn't have to worry about it. Now, it says when you need to escape more than one character in a string, it's best to use the double quotes. And we've seen that, right? we seen where we had the single quote and the double quote. We could have easily taken this and just did this here and got the same results, right? And we could have put it in single quotes, right? And in your for loop, and you'll find this out later on, the double quotes and the single quotes act differently. I think the single quotes make it look at it character by character, whereas the double quote make it look at it string by string. Don't quote me on that. I think that's the truth there. All right, so here we didn't get anything when we do as a comment. Then we get something when we do it as a comment, but we don't get this last line. You see that? I mean, you don't get this last pound sign because we didn't escape it. And then here they escape it, and then here they just put it in double quotes. And I showed you the difference between the double quotes and the single quotes. And then if you want to take it one step further, if you want to come here and do the backticks at the top, that should not work. Yeah, and I think that would work because it's not doing an act on anything. It's not an act. It's actually just some string. All right. So it's showing here using the double quotation marks to suppress the globbing in the shell expression, but still allow the command and the variable substitution. And they're getting into variable substitution down here, and this is where I was headed with this. And you've seen me go over this before. So here, they have inside of here the results get stored of hostname dash s. So what does hostname dash s do? And let's clear, and we can do a hostname dash dash help. And so the dash s gives it the short host name, the dash d gives it the domain, um, the dash f gives you the long name. They're just saying we want the short name, right? And so if you do host name dash s, that's giving us the name. If we give it the dash f, was it the full name? Yep. I guess I don't have a domain, so it's not giving me that. So let's go back to our alias that we were working on before when we did a host name equal to right now we're setting a variable basically to host name dash s, right? And now if I echo $ host name, you can see I have instance dash 2. Well, if we look right here, I I'm pretty much accomplishing the same thing, except they're using this inside. Like this works great inside of a for loop, right? So let's take what they did there. So let's go back over here and say um use the up arrow at this point. And let's do a $ here. And then let's come back over here and do that, right? And now if we just echo $host name, you can see I get instance 2, right? So basically, all it did was interpret this information for me and then stored it into this variable and echo it out. And I showed you how that worked, right? You've seen that 2 different ways. So down here, when they're doing this echo host name $bracket $bracket var bracket, you see the output there, right? So let's go ahead and we can do the same thing. We can switch it up with pound signs or percent signs if we want to. And then let's do this. Let's do $ host name and let's see what we get. Because there's a difference between these. All right, so we got that. Now when I come back over here and I do the interpretation of that, right? So what's the difference between the two? What's the difference in doing it this way and then doing it this way? Right? They both give me the same
The
results.
same.
All right? But there is a difference between those. Anybody want to take a look, take a stab at it? No? No stab? Okay. So the my best interpretation of this, let's go look it up so we make sure I'm telling you right. Here is we're actually returning in this case we're actually returning the string results, and I think this one is a reference to. So let me double verify that. Um Linux reference to variable. Let's see. All right, let's blow that up a little bit there. Make sure I'm telling you right on that. So we got echo. Let me see if they got any brackets down here. That's what I'm looking for. No, no brackets on that one. Mm, yeah. Oh, all right. Yep. So here we go. Okay. All right. In most situations, both the $var and $bracket var are the same. Note that you must not use the $ at the end. Okay. One example is you need the curly braces. You need curly braces are when you need to put a variable in a continuous string. Right here. So $bracket variable. In other words, okay, that makes sense. And then there's another part to that. So basically, and you see that example too, right? So if I say var equals to TOO, right? And then I say echo um $, uh let's do this var um go, right? You see, it didn't know what to do with that. You see that? But if I come back here and put it in the brackets, it should print out to go.
Oh, I see.
You see that?
Yeah.
All right. It looked at var as var go as an entire variable
Yeah.
versus this saying, hey, take. And this is why I say I use this in for loops when I want to say, hey, I want to increment a variable that may be one, so it'd be like one dash, or well, one, like I can do like this. Hold up, one dash go or something like that, so I can always change the number or something like that. So that's what that comes into play. Let's see if we got another interpretation of this. Um, yeah. So to answer your main question, $food is called parameter expression. To be precise, the $ starts the parameter expression. The brackets are actually optional in a positive sense. So here they got like here echo foo base fails, no variable name foo base. You see that? We showed that. And then here when we do a $ foo base, it's gonna interpret that bar and then show bays, so bar bays. And it says basically they're identical apart from the cases like above or when you need to do string manipulation. Got it? I give y'all this one as something you can refer to. So if somebody ever asks you again what the difference is, now you know how to use it and what the differences are. All right. So here we can kind of breeze through this. Echo will variable var up here is host name and its host evaluate to host. So basically will variable host evaluate to host. Yes. Echo will variable $var, which is host, evaluate to host. $host. Oh, but I think here what happens with that one is uh it didn't evaluate here. So look here. So we have a double quote which took it as a string, and then the single quote didn't do that. It left it uninterpreted. And this is what I was talking about for before. It says the you see the single tick, I mean not single, yeah, single tick did interpret the variable var, so it didn't give it host, and it didn't interpret the host name. It didn't execute that. It just took it as as I think this is where it comes in, where it's straight taking it character by character versus a string, and you can see that here. So that's the difference between the double quote and the single quote. And then down here, this is where we talk about the escape. So basically, when you're doing an echo, so whenever I do echo, um, home slash space, well, let's do slash um, um, pound sign, come get me. What do you think it's gonna do? It's gonna. It was supposed to take that and escape it. However, down here, if I would do, and I don't even need this because it's gonna just print out that. And let's go here and let's do one more thing before we do this. Let's do single quotes and see what we get. So we can show some differences. Same thing. Cool. But down here, you see what this slash is at? It's escaping um that actual extra double quote. And then it's escaping this extra double quote so it can print the double quote. Another way around that, and this gets funky, is to put single quotes. Now, when you're doing this stuff, make sure you line up your double quotes and your single quotes right, because if not, you're gonna get an error and it's gonna throw your stuff off. So let me show you what they talking about here. So in here, it's gonna echo, but what happens is this they want this part to print this single quote of this single quotation here with hello and what's in front of that. So we can actually probably change that to let's change that to, let's see, star. Oh no, I can't get that. Hold on, what else can I change that to that's got an upper well, I might could do star. Let's see. It shouldn't matter with the stars though. See, okay, you notice that? You see I got my slashes in there. You see how that changed it? Now if I go back and do the double quote, I'll get it. I'll get the just the hello. You see that? So the double quotes with the star in front of it, it interpreted everything. It took everything. And when I did put the double quotes in there, it just escaped this character. So when we're using the escape of this, we're looking at the double quote here and here to be printed out. Let's try it with a single quote. single quote the same thing. However, if you take that and flip it with a single quote on the outside, like they have down there. Oh, I should have did it. Hello world. Do I have space? Oh, sorry. I got my spaces in there. I mean, I got my slashes in there. So it's just it interprets everything that way. Do these single quotes, back quotes, and backticks make sense to you? Because it's gonna matter when you put this in the script.
Yeah.
Okay. All right. So here we know cat being hello. There's no hello script. Basically, they'll like echo a word out or phrase out called hello. Run. You make sure you have it chmod plus X on it, so it can be executable, and then run it. And that's that one. Same thing here. Echo hello world. Echo error. Houston, we have a problem. And who remembers this standard error? Who remembers that?
You ignore the errors for 2.
Yep. And then what about here? Hello to, and then hello dot log. Hello well greater than 2. And then hello dot log. Let's try it. Let's just grab this. Oops. Has this explanation made sense to everybody? All right, so that's fine there. Oopsie. All right, so it's already set to chmod plus X on it. So when I do hello.text, it says hello. And I can also do this hello, and it should run as a script. Right. So now when I do hello here, let's do exactly how they have it. To, and then hello.log. Right. So we didn't get the error. All right. It didn't print out the error for me. If we do a cat on hello.log, it caught that error. You saw that? So here, when I did hello to, well, first I ran the script hello, right, and it printed everything for me. Then I said, well, capture the error and store it into a log file, and then when I cat that log file, we have that in that log file. And this helps you when you're writing your scripts to capture all your errors. So if you write a script and it runs and you're trying to figure out what errors are out there in your script, or if something fails, this is a good way to capture those failures. And that's primarily what they went through there for this one. So the next one up is to automate sequences of command by writing a shell script, efficiently run commands over a list of items in a script, and then find matching text. All right, so let's do the next one up. All right, so they start up a lab console. I'm not gonna create a lab console. Let's just walk through what they have you doing. What's this first line called right here? What's this called?
Shebang.
All right. What are these echo lines doing? When we see echo, what's the first thing we're thinking?
Printing something to the screen, but now you're redirecting to output.txt
Yep.
in your home directory.
Right. And then here, what's this line doing?
You're saying print an empty line and append it to that file. So like a space.
Yep. And then here,
Put that thing in there and append it to the last line.
that's it.
No.
And then they got sh the script, the first script, and then this will be the output. And you should be able to read through a bash script just like that. Like, okay, this is the shebang. This is doing some output. It's redirecting. Redirecting. This is appending. This is appending. What's in the echo statement? What's the $ 012? What's bang, or I mean uh £. Like, we should be able to read through that. All right, so let's look at this again. Let's see. So we got the shebang. We're doing what? So output, redirect. Okay, now here we got list, echo list block devices. So it's appending to that same file, putting in a space. It's running a command. Now, here's the trick. Is ls block in the path of that user? It has to be of this user, right? Server A, this on server A, that student user has to have the ability to run ls block to do that. So let's go try. I'm on my other machine. Can I run ls block as a regular user? Yes. So it's in the path, and if we say which ls block is user bin ls block. If it would have been user s bin or maybe s bin ls block, we might not have been able to do that. All right. So we verified that we can run that and append that to this file, put me a blank line in, put in this in, and now let's see the file system that is free space, and can we append that output to the same file? Yes, we can. Now here they say file make this file executable using a chmod. They're just adding chmod all plus X to everybody. That's what they're doing there. And then they run the script and then they give the output here. And that's basically the lab. Did that make sense? Walking through that so that when you're going through this lab, take time to read what they want you to do and then do it. Don't just do it. Read what they want you to do, see if you understand what you think the results are supposed to be, and then do it. All right.
I got a
That's,
question.
yep.
Do we have to put that file for the home directory if you're already there? The path.
If you don't want to, that's just their way of saying.
Okay.
That's just their way of saying I want you to write that right there. That's just their way of saying it. But no, you don't have to.
Okay.
All right. For loops. All right. Yeah, this is the fun stuff. So for loops in a command on the command line and for loops in a script are gonna be a little different, but they're the same but a little different. So they give you an overall structure of what a for loop looks like. So for some variable, uh, which could be, and usually when we do these variables, we want to use what we call the God, what is it called? Gosh, it's called the cat something. I forget the camel. That's what it is. I was getting ready to say something else, but it's called a camel selection. So basically, if I do for my user like that, that's usually camel case. That's usually how most people want you to do it. In some cases, most people just do this. In one, I think you do 1, 2, 3. Don't quote me on that, and that may be wrong. I think it may be just space. 1, 2, 3. I think
Yeah,
that's what
there's
it
no
is.
comma.
Yep. And then oops, 3. And then do And then here we're gonna say just echo $ my user, right? And done. And so there we go. 1, 2, 3. Right. So that's the simple way of a for loop that's just showing you here for variable. But what if I didn't want to have uh 1, 2, 3 as a list like that, right? And this is going to be a rule of thumb for you. You have to figure out when to use bash and when to use something else, because bash doesn't give you uh everything. It doesn't give you everything accessible to break things down. For example, bash will give you an array, Python will give you an array, but to get sub particles out of an array, or to get an array, to get information out of an array and then break the array down a little further, it's more than likely easier to do it in Python. And then some people find Go a little easier than what they do Python. And then some people like Rust. It's all it's person dependent, company dependent. But the Python, Bash, Rust are probably going to be your go-to on a lot of things, especially when it comes to creating APIs and working with applications. So it's just a FYI. So in here they talk about the string provided is a list in order one by one, and they also talk about how to process a variable. So remember before we did echo $ my user, and let's just do dash do, and then let's do this. Um, let's add on to that. Let's play around here. So here I said, before I said let's do 1, 2, 3. Now I say for my user, echo me my user 1 dash do, and then remember I added, now I add that bracket in for, remember we talking about variable expansion. 1 do 1, 2 do 2, 3 do 3, right? And I can even take that one step further and just take this dash out, and it should interpret that. 1 do 1, 1 do 2 do 2, 3 do 3. You see, and that's out the variable expansion. Well, I mean with the variable expansion, but without the dash. Make sense? And so that's what they drop down here and show you. So they come down here and they go host. They give you a list. So we remember we sticking with our same structure for a variable, which is they name it host in list, and then here's their list, echo the host, and then done. In here they're doing that 1, 2, 3, right? So in here, remember uh you can do the actual comma, the host, or you could do 1 through 3, and you see the results are the same, right? So in here they say for file in file star, do a ls $file. So, and I don't have this set up on my machine. I'll try to run this, but I don't think it's gonna work because I don't have a file, a list of files there. Let's see what happens though. Yeah, I don't have no files. I don't have no files on my machine, but I can touch file, and let's do 1, 2, 3, and let's do it ls file 1, file 2, file 3. And now when I do files, it says for file and file. And remember, file star meaning anything that starts with file and anything afterwards. So let's go back. Let's go back. Let's go back. Let's go back. And then hold on. And then let's do do BCA. Right. And then let's do it ls -l. So now I have some files 1, 2, 3, A, B, C, and do, right? So when I run this command, it's checking for everything that starts with file and then a wildcard after that, and then do a ls on $ file and then done. So here just did a ls on that file. But if I do a ls minus LH, it's going to give me a little bit more information on that, right? So you see what happened there. Did that make sense, what I just did? I can even,
Yes.
okay, I can even do, I should be able to do anything FIL star, right? It's going to give me everything. And I should be able to do, um, let's try this. Let's try beginning with file. Okay, it doesn't like that. It doesn't like that character, but let's I don't think single quote would work. I think this is when you have to get into, I think you have to just stick to the file like this. Forgive me the wild card. But what if I want to do something that start with file? How would I do that without the file star? Can I do that? I don't think it's going to interpret that. Yeah. And I don't think I can do it with a, that doesn't make sense because that's not a command. Yep. Yep. I have to look at that on how to take it and say, look for everything that starts with a file. And this is when you get into your for loops and greps and all of that stuff. But for now, that works. All right, here for a file in file A through C, do a $ file. So basically, I'll try to put it in parentheses. Mm, but I think that doesn't work. You mean like this? Yeah, I figured that wouldn't work. I had to look at that. So here, let's do what they have here. They're looking for everything with file and then ending in anything A through C bracket. And then you see you have A, B, C. You see I didn't get the D because I didn't include that, but let's go back and just add D here. Okay. Yeah, no, nothing called file D. Can't access it. That makes sense. But if I do, what if I could do file D star? Would that work? Nope, no star. Doesn't like it. But I can do D star on this one, and it'll find it. But it wouldn't let me do file D D star, and then like the wild card. So just how you learn how you play around with stuff. And then in here, we should be able to interpret this. So let's walk through it. So for what is package? What is package in this case?
A command.
No, package is our variable.
Variable.
Yep, that's our loop variable. Yep. And in this case, when we have this right here, we went through this before. We could use the backticks, so we could put this in parentheses, but this is our actual, we're running a command that's going to return us a list. And we know that by taking this command and running this command like this, right? We got a list, right? It's going to return us a list. So let's do that. for kernel or package, we'll stick with what they have, and they use capital in our case. So, but I want to show you this. All right, do an echo package, and then done. All right, so all I did was say give me a for loop, and I put in single ticks to do echo the package, which is my variable that I define here, and then done. And you can see I got the results. And I can do the same thing that they're doing uh, if I wanted to. So in here, we know what this does, right? And we know what this part does. And what you see right here, this right here is a continuation of the script. So I can write it on multiple lines. It tells me that I'm not done. That's all this is telling me. That when you write this, you're not done. Keep going. And then the echo part is package was installed on, and then again, this is an interpretation here, right? Here's the rest of that, right? Uh here's that closed and that closed. Um Package. Okay, and that one is closed. All right, so remember I say your double quotes need to line up. That double quote right there goes with that double quote, and then that double quote goes back over here with this double quote. So then they're giving you a command with the dash state D, and then this at dollar sign. Let me see. I guess it's at RPM dash QF. The install time, that's a variable that goes uh that's under RPM, and then the package name, and then done. All right, let's run it. Let me show you how it should work. Let's see what this at sign does for us. Let's clear that. All right, so now let's go back up here and see what did the at sign do. So for the package, we know what that is. We know what this is, but right here where we got the date dash D at dollar sign install time, um, and a new line, which is you see your new line, and then dollar sign package, and then done. And you can see all of that. Let's clear and run it again. Let's break it down. Okay, so we got our first one. We're gonna print that package was installed right there on, and then we have a slash that got printed out because it is inside the double quote. Right, so we get that slash, and then it gives us the time. Gives us the date, install time of said package. All right, so now if we go do a man on RPM, and let's grab this, and then let's look up this. Not there. All right, so let's do RPM dash dash help, and it's grep. They don't have it. This must be a supplement. Its install time has to be part of this RPM query. Let me go up and look up. Let's look up install, and it may be a part of date. Let's look up install. Let's look up time. So there's the date, string, reference time, Unix time, M time. Let's see, I don't see that. So let's go back here. I just want to know so you can see where that comes from. Okay, formatting. All right. All right. Okay, here we go. That's what I was looking for right here. So it's a format. It's a query format. So the query format, you can get the name and install time and then the date. So when we have ours, when we're doing ours, clear our little for loop. This is our format. That dash dash QF is our format. Give me the install time in a format, and then the date dash D. If you do a man on date, um, here's the dash D string. Display time described by string. All right, so let's go back. Dash D. Okay, so this is a string. That's where that comes from. That's a string for date, and then the package. You see how I went through and broke it down? You always know what each one does. So it interprets that as a string. Yep. And I'm just going through here, see if they give any examples. See, right here, the @ sign. All right, that makes sense. So that all of that was, we could use my screen. All of that was interpret, give me the package, query everything, RPM-QA, query all RPMs, grep for kernel, the word kernel, and then print the package that was installed on the date, on this date, and it gives you the date and the format of that date install time. We can replace that with uh, uh, something else if we wanted to. But they doing install time as the tag that they're using for the query format. And we could replace that query format with different variables here that we have. Let me see. Where did those variables query format go? So long archive size, yeah, we could replace it with version, release, epoch, build time, build host. We could replace those tags, their actual tags. And then the @ sign is required for the variable date here to do that. So that's how you should be looking at these. You should be breaking it down one by one, like what is this actually doing? How, and figuring out how that works and where's the @ sign coming from. The @ sign is part of the date, how the date should be interpreted, and so forth. Here they're talking about doing a sequence for even and sequence from sequence 2 to 10. I think it's adding every 2. I think that is. Let me double check on sequence. So we do bash sequence example. All right, so sequence 5. So add 2 all the way up to 20. 5, 7, 9, 11, blah blah blah. That's what that is. All right. So in our case here, add 2 all the way up to 10 and print even. So it's going to print all the even numbers 2, 4, 6, 8, 10, and then done. All right, so then they talk about exit codes. So these exit codes are, whether it resulted in a 0 for being that it ran and no errors, or a 1 and it ran with an error. So in our case, we could do echo dollar echo question mark. Is it dollar question? Yeah, dollar sign question mark. All right. So that's how we know that whatever the last script that ran returned an a 1. I mean a 0. So all right, I figured that. And so when I run hello, and then if I do echo, not echo, if I do the same thing that we just did here, echo dollar sign, question mark, I should not get a 1, should I? I mean a 0. I should not get a, yeah, I should not get a 1. Um, because it actually ran. But if there was an error in here, so let's go hello, and then let's put um meow, and then let's run it, and then let's do, and you can see that I got some kind of error code, right? That's it. You're just looking for, if it doesn't return a 0, then you know there's some type of error. And it says if exit is called out with an argument, then the script exits and passes in the exit status of the last command executed to the parent process. So now they want you to put different tests in. So you could do different tests inside of bash scripts. And so here they're doing tests. If 1 is greater than 0, then echo that the command was successful or not, right? And then if 0 is greater than 1, echo whether it's a success or not. Is 1 greater than 0? Yes. Is 0 greater than 1? No. And so there's test on strings, and then there's test on numbers. And you have to know which one that you're going to be using. So bash test on strings, right? So look, you see there what we start doing right here, not equal to the regular expression returns if the left hand operator matches the extended regular expression on the right. Are the two strings greater than each other? Are they a 0? Is it a non-zero? It's totally different than what it is for when you're comparing two numbers. And if you want something to be a number, don't put it in double quotes and single quotes. If you want something to be a string, then you put it in double quotes and single quotes. It's something that you need to be aware of. All right. So here they're testing numbers. All right. So here, does 1 equal 1? Does 1 not equal 1? Is 8 greater than 2? Is 2, is that greater than equal? I think that's greater than equal to 2. Less than 2, and 1 less than 2. And they're walking you through it. So I want you to notice something as we do test. If you noticed anything different, you should notice that these brackets pop up. You should notice that. Let's go here and see if we just write it on our command line. Right? the brackets pop up to let us know that inside of this bracket, I need to execute that first. And if that result, whatever that result is, should be this dollar sign question mark is going to tell me whether that was uh, zero or, zero or a one. So let's go back and add in, let's put in 0. And you see I get a 1, right? So it's some type of error there. All right. So here they're doing string comparison where they're doing ABC equal to ABC, which is totally different than equals equals, right? Um, does ABC equal to ABC? Yes, but does ABC equal equal? In other words, it's going to do, I think equal equals does a string by, does a character by character comparison versus equal does a string compare. Let's double verify that. Let's see. All right, here we go. Use the equal operator to test with the test with brackets and use the equal with the double brackets. So you got to have double brackets. All right, right here. String 1 equal to string 2 and string 1 equal to the equality operator returns true if the operands are equal. And they say you have to use it this way. I got it. I think one of them checks for characters, character by character, and the other one compares strings. Let me see. All right, down here, you put the test in brackets like we've been doing, and check if the strings are equal or not equal. So var1 and var2, print if they're equal or not equal. Strings are equal. Here is another script that takes the input from the user and compares the strings. So we reading from command standard in or command line, and then it does it on an equal equal. And then here, this is where I get into that logical and that logical or. So with an and, let's go, and I went over this before, a true logical and truth table. And we've seen this before. That's one right there, but I just want to go on images and blow it up. That's fine. So basically, if it has to be true and true for it to be true, false and false to be false. But if it's true and false, it's false. If it's false and true, it's false. And the or does one or the other. Like if it's true and false, if it's true or false, it's true. If it's false or false, it's false. If it's false or true, it's true. And if it's false or false, it's false. So that's the difference. These are called truth tables. Logical and logical ors. And when we're talking about logic and circuits and so forth, that's where this come from. And so here they're doing an and, they're testing this, and does equal not the and does an echo equal or not equal, and then they put what it is. So this had to return true or false, right? And if it's not equal, that's what it returns. Not equal or false, then not equal. Does that make sense? Looking at this, does this make sense? I feel like it may not make sense to you. Okay, I guess it makes sense. All right.
Wait,
It
what
makes
is in
sense.
string 1 and 2 again?
What'd you say now?
What's in string 1 and 2?
Up here, string 1 and 2 is whatever's being pulled in from the command line right
Oh,
now.
command line. Okay.
Yeah, they're just pulling something in, so you could make string 1 and string 2 whatever you want it to be. That, scratch that. String 1 and string 2 is what you see here. So look,
Oh, okay, okay.
yeah, it's what you see. It's a test. It's a string.
Okay. It's not calling a variable. Okay. I was thinking
Yeah,
it was a variable. Okay.
no, it's not. It's the
Okay,
string
okay.
1 2.
Yeah.
The one above it is calling in a variable.
Yeah.
But you can easily change this to instead of logical or put a logical and. Look at that. They didn't return anything. It should
Hmm.
return. Oh, I guess.
No,
Yeah,
it's not
it's
going.
true. Yeah. So if string 1 and string 2, and yeah, so it's not gonna return anything. But if we go back and put that in, boom. So compare string 1. Does string 1 equal to string 2? No. And equal and okay, it's gonna interpret this side over here. And echo equal or echo not equal. So it's doing an and here. The and this side has to be true for this to be true, or this side has to be false for this to be false. But it gave a or. You follow what I'm saying? So if you interpret the left side first, string 1 and string 2, they are not equal. So that's gonna give us that, gonna throw us that 1. And then if we echo equal or echo not equal, these two have to be this and saying like, hey, these two have to be either true true or false false. And it's neither, so it don't return anything.
Hmm.
That's what the and does. Remember on the truth table, they both have to be true and they both have to be false in order to get some type of result. Well, true, true, false, false, true, false, false, true. All right. And then they hop down here. They're doing follow and demonstrate the bash string comparison operators. Does that return anything equal, equal, and does not equal? And again, on strings. Doing this strictly on strings. And then string urinary operators. All right. All right. Urinary operators return a string, a numeric, or a logical value. They have and this is where it comes in at. They have a higher precedence than other operators and are evaluated first. So the type of operator is matters as well. So that's what they're showing here. The urinary operators. So they got a string, it's empty, and dash Z, I forget what dash E is. Dash E bash string compare. Forget what dash Z stands for. May have to look it up. What is dash Z? They don't have that. Let me see. They tell us what it is. Space, blah, 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 blah. Shell, compare, blah, blah, blah. Conditionals. Yeah. Well, no, they don't tell us what the dash C is. I have to look it up. I have to look up dash G and dash N. These are string urinary operators. So let's go example. Let's look this up. All right. Read length, substrings. I don't see the dash Z, so let's go dash Z. No, dash N. Nope. Mm, yeah, yeah. I don't see dash Z and dash N. And this right here, these are the ones I was talking about earlier. These special um characters here. This is parameters. That's what I was talking about earlier. And I don't see the dash G and dash N. I'm gonna have to look that one up and get back to you because I see they don't even explain it in here with the dash Z and the dash N, whatever they do. So I'll have to look those up and send it up. I forget what they stand for. And then here, so you can say, hey, if if you return a true statement, then print the statement. Or if you return true, do something else. If you return false, do something else. And this gets into if else if when we're talking about statements. So we got an if then we got if then else, and they talk about the construct of that, and then if then else if then else, right? And it's just all about looping. As we go through this, I'm not gonna go over it tonight. I'll go over it next week. I won't go into your conditional structures tonight. And I'm gonna go back over this next week so we can make sure we have that. But I encourage you to practice the difference between uh testing a number and testing a variable. This will be an interview question when you're going through it. They will ask you this in an interview, like how to compare a string, how to compare a number. How would you do that? And then if I get that these two strings are the same, how do I what do I do next after I get these two strings are the same? Got it? And then let's see what else they got in this chapter. This a guided exercise. They walk you through the exercise. And then matching text in a command output with regular expression. And then they have a video for regular expression. And we've done some of this matching with start and end of the line, describing regular expression, um, wildcards, and then this is when they start getting into like, hey, a digit, a lower, punctuation upper. This is gonna be your fun class. This one's gonna be fun because you're gonna use these throughout your career. And then after they do that, they give you a guided exercise and then a lab and a summer. So we should be finishing up one come next week. Let's look at the table of contents. Two gets into scheduling and jobs. I'll probably have to spin up my lab because they probably got some type of script that's gonna eat up something. Adjusting tuning profiles. I think we can. I think the third week we could do 3 and 4. The fifth week we'll probably spend 2 weeks on SE Linux, and then 6 and 7 should run together. 8 I'll do by itself. 9 that should be really quick and easy. 10 and 10 I'll hold off because, well, I may do it at the same time, but I may hold off on it because I'm gonna need day lab for that. 11 and 11 should be fairly straightforward. That may tie that back in with SE Linux chapter 11. And then chapter 12, uh, we can knock that out. That may be in a 2.5 hour class. And then 13 is where I spend most of the time going through containers. But for the most part, come next week, we're going to do the rest of 1 and 2. And then the third week, we'll do 3 and 4. And then we can do 5 by itself, and then the 6 weeks, 6 and 7. So you have the material. I advise you to read ahead, knowing how we're gonna walk through things. Some of this should be like a flashback to you when we're doing this. Um, the boot process, that's just something we just gonna have to do in their environment, because they probably want you to destroy the root password, and then you got to recover the root password, and then mess up the file system and keep it from booting, and then going into rescue mode and making whatever changes you need to make, and then making sure those stick, and then make sure you mount it, then make sure they stick, and then reboot the system, and make sure it can go past reboots, like you don't get the same error over and over again. And that's pretty much it. Any questions? Then you can start recording.